ouais, c'est bon. Sur le programme que nous on a, normalement ça c'était 17h, 17h30, la conclusion de la conférence, 17h30, 18h30, d'ici la seconde. Bon. Du coup, vous allez reprocher d'une demi-heure, c'est bon? Ouais, d'accord.
Okay, one more information about the permanent exhibition in the venue, just to confirm. So the exhibition is closing at 6 p.m. and the last floor to get a glass of wine after the visit is closing at 6:20. Okay? So feel free to enjoy.
And next talk is Bruce Richardson, one of the oldest, earliest contributor in DPDK. And the presentation is about the Maison build system, the new build system in DPDK.
Morning all folks. Hope at this stage everybody's had a chance to wake up and isn't too sleepy. At least I didn't get the straight after lunch slot. I got straight after break. So hopefully it's not too bad. So this is just a short talk. Now can you hear me better? Yes, okay, good, good. So this is a short talk on the current status of the Maison build system. So I've talked about this previously, and I'm sure most people, or I hope at this stage, most people are aware that we have currently two build systems in DPDK. There's the original make build system, and we've got a new Maison build system. So a little bit of history before I dig into the current status. So there's the original make build system has been around since the earliest days of DPDK, the pre 1.0 even DPDK. However, it hit a number of problems a couple of years ago. I won't go into all of them, but one of the most pressing ones was it lacked any sort of dynamic configurability. You had to go and manually edit the build configuration files if you wanted to make any changes to your DPDK build, and was kind of inflexible, and it didn't do real dependency tracking and the like. So we looked for an alternative way of doing things. There were a number of options considered, including trying to roll our own set of scripts around the make build system, but in the end of the day, we introduced an alternative build system based on the Maison tool and Ninja as a replacement for the actual make step. So Maison handles the configuration. It's like your configure script with auto tools, or it's also equivalent to, let's say, CMake. And then Ninja does the actual compilation steps, runs the compilation steps. It's more a direct replacement for make. So this new build system was introduced in 2017 and has been in ongoing development ever since. More and more pieces added. There's been quite a lot of functionality and tooling based around the make build system over the years that has had to be duplicated or re-implemented in Maison and Ninja to make it work, but we're coming near the end of that. So at this point in the technical board, we were discussing and have discussed a number of times over the past year our plans for deprecating the make build system and just transitioning over to just having Maison, because there is obviously an overhead in having to maintain two parallel build systems, and we'd like to get it down to one way of doing everything. Okay? So with Maison build, what's currently implemented? Okay, so we start off with the good stuff, and then we move on to the bad stuff, what's not done yet. We'll get to that later. But let's look at what's done. We have had for quite a while now, we've had all the libraries building. We have all the drivers, as far as I'm aware. If somebody is aware of a driver that has been missed somewhere, please let me know after, or possibly let Luca Bacassi know as well. Luca, wherever you are, he's been a great help in doing a lot of work on Maison as well. So we've got all the drivers building, including PMD info. which actually was working from the very first versions of the patches. I think I posted up. We have all the test applications, so test PMD, the auto test, test ACL, all of those are building. And we have the examples bar, I don't know, 3, 4 examples currently are not supported as part of a main build yet. The reason for this is that the actual sample application code is located in subdirectories. So there's a few applications that have subdirectories, and we haven't provided support for that in the infrastructure just yet. But they're few and far between. I don't know how many examples we have in DPDK. There's dozens and dozens, and I think it's maybe 5 aren't implemented. Okay. We also support building the documentation in HTML form. Okay, so that's already done as well. So the pieces that are missing are listed here. And again, if somebody is aware of something else that's missing, please let us know so that we can go to fix it. Okay. So the build of the PDF documentation is a lot more awkward than building the documentation as HTML. I'm actually not sure how many people, or can I get a show of hands? Has anybody actually looked to build the PDF docs or use the PDF docs? 1 or 2 people. Okay. Because I would suspect that the HTML docs are much more widely used, and they're certainly easier to build. The PDF docs using LaTeX it's rather awkward. So that's not fully implemented yet. Luca has been looking at it, but it's not there yet. In terms of tooling, the main tooling gaps, or the biggest one certainly, is the experimental tags checking script, which is the script that looks at our map file and checks that the functions listed are experimental, matches with the code, the functions in the code that are actually tagged as experimental. So that support has not yet been integrated. Nobody started looking at it. It's on my to-do list. So that's one gap. We don't have an equivalent of the make tags command. As far as I'm concerned, that's not a huge gap because the script is just in the DevTools directory, and you can actually run the shell script that makes calls. You can actually run it directly. So maybe that's one that we just update the documentation instead, and say instead of calling make tags, you just call DevTools create tags, or whatever the name of the script is. I can't remember exactly. We're missing we could do with a bit more documentation. There's, in the programmer's guide, for instance, there's a full chapter on the make build system and how it all hangs together. We don't yet have an equivalent for Meson for that, but we do have some decent enough documentation, at least in my opinion, in the contributor's guide about how you can actually use create the meson.build file for a new library or new driver that you're adding to the system. Okay. Then one last gap that was not in the original version of this slide, and it's one that myself and others on the tech board and Luke and a few others were looking for some feedback from the community on, is around the whole area of configurability. Okay, so I'm actually going to just spend a minute or two talking a bit about this. Okay, if you look at our make build system, we have in the build config file, we have an entry for every single library and driver. Well, at least one entry for every single library and driver inside DPDK. So you can turn on and off drivers and libraries depending on how much of DPDK you want to build. Okay, for Meson, whenever we were switching build system, one of the original plans that those of us working on it had was that we would remove this, that you would build DPDK as a complete product in one go, and some parts, yes, could not be built maybe on BSD or could not be built on Windows. But as far as is possible, if something could be built, it would be built. Okay, and some of the reasons why we wanted to avoid that are called out here, particularly on the disadvantages side, especially just looking at terms of testing. We had lots of people or issues coming up about if I turn off this library here, the build fails because something else in the build depends on it. Okay, so the open question is, how much configurability do we want or do we need as part of the Meson build system? Okay, I'm actually quite in favor of not having things too configurable myself, and I know some other people feel the same way, but on the other hand, there are others in the community who are really looking to turn things on and off. So going through just the advantages and disadvantages, if we have the configurability like we have in Make to turn on and off components, we can have smaller builds, faster builds. We can also have more targeted builds, okay? And we can then have easier validation of a smaller package because you've got fewer components in it, okay? My thinking on this was, as well, is that whenever we were very much focused on static builds and static linking of everything into the one package, this kind of made sense. But if we want to move as a community to DPDK as a product that's included in your Linux distribution that ships out with shared libraries, maybe that's not the way we want to go. We want to have just one package, one definition of what DPDK is. So the disadvantages beyond this for having this ability to turn on and off the components are, well, firstly, that each package may be different. We don't really want to end up in a situation where somebody develops an application on one Linux distribution using DPDK and then moves that application to a different Linux distribution, and the application stops working because they were using one of the DPDK libraries or one of the DPDK drivers that had an API that's no longer present on the second distribution. We'd like just DPDK is DPDK. Then the code itself, and this is the one that perhaps gets me the most, the code itself then needs to take account of the fact that different parts can be turned on and off. So if we have test PMD is one good example. It has got a number of extra library dependencies beyond the PMDs. If we have the ability to turn those libraries off, that means then we need if-defs in the code of test PMD to take account of the fact that build time, that library may no longer be present. Okay. Then the build system itself needs a dependency tracking. With Meson, this isn't actually that hard. We're kind of doing it anyway, and it's not a lot of code, but it is still more code that has to be maintained, even if it is, only 20, 30 lines across the whole build system. Okay. And there's more things that can go wrong and more things that need to be tested. And it's really testing where we see the biggest disadvantage for me of this. We have in total about 50 libraries, I think, in DPDK right now, give or take a few, okay? So if we say 10 of those are core libraries that nobody should ever turn off, okay? I mean, we can't support turning off EAL when building DPDK. We can't support turning off mempool, okay? The rest, though, we might be able to. So that would mean about 40 libraries that you could turn on and off independently. We have a whole bunch of drivers. If we exclude the bus drivers, we come up with about 90 different drivers. So that's 130 components, each of which you could turn on and off individually, which gives you 2 to the power of 130 combinations. And if we say that 2 to the power of 10 is about 1,000, that's 10 to the power of 39 possible combinations you could have of DPDK builds. So there's obviously no way we would ever be able to test all of those possible combinations. So what do? We just say that this is okay if you allow you to turn things off, but if it breaks, it's on you? Or what's our approach here? Because it's infeasible to test anything like the number of combinations we would get if we allow people to start turning on and off individual packages. So are the advantages outweighing the disadvantages? The last point then was just from the ABI discussion yesterday. We're talking about standardizing the DPDK ABI so that we keep it constant. The question is what's included in that ABI. So if you have a package that's missing 2 of the libraries, well, does it conform to the DPDK 20 ABI or not? Because it's missing some of the functions. So that's an additional consideration. So my bias may be showing through here in terms of having far more disadvantages than advantages, because I'm not a particular fan of this, but if the community feels it's necessary, maybe we need to add it. So I am looking maybe in the questions afterwards, people could give their comments or their thoughts on this, how much configurability do we need? Maybe it's just the case we say, well, all the libraries, they always have to be built to keep the ABI, but the drivers, you can turn on and off the drivers for your build because you know what hardware you're going to be running on. So there may be some halfway house, maybe some compromise on it. Okay. So moving beyond that whole configurability open question, there's then the issue of what to do with the make build system and deprecation plan. So this is one proposal. This has been discussed at the technical board, but we haven't really filled out all the details and haven't agreed on all the details. So again, we're looking for community feedback and community input on this. So our thinking is that it needs to be probably across at least 2 releases or 3 releases of DPDK. So one suggestion is that we would just, in DPDK 1911, just mark the make build system as deprecated. Okay, you can still use it, it still all works. Nothing changes except in our documentation, we tell you this is now deprecated. Then a release or two later, we could add just an additional message or an additional step. Whenever you run make, do something like print out a message saying the make build system is now deprecated. Do you want to continue, yes or no? You type yes, off it goes. Allow you to override it so you can still use it from scripts. Allow you maybe to pass a y=1 flag. It'll skip the question and off you go. Just to put that additional roadblock to make people really aware that this is going to go away. And then at some point in the future, when we've got all the gaps I talked about closed, maybe 2005, maybe 2008, hopefully before 2011, so we don't have to maintain it longer term in an LTS release, we want to actually remove the make build system, because it's got quite a bit of code then in DPDK we could take out and no longer have to maintain. So this is, again, our thinking on this. 1911, I think we agreed at the last technical board we will mark it as deprecated, but no other changes. Subject to confirmation from the other tech board members that I remembered our last meeting correctly. It's the steps beyond that. How long do we need between just putting our documentation saying it's deprecated and actually taking it out? So feedback looked for on that. So this is a short slot, so that's basically me done. I'm opening it up for questions or feedback. So I see a couple of questions over here.
So have you tested, because I've run into this, but I haven't tried it in a while, OVS, right? OVS didn't respond well to Maison because the libraries were all in a different place, or packet gen, DPDK packet gen. Are they going to work with Maison?
Well, I'm not sure what the status of the integration with these are. This has been on the go for 2 years now. So this is why we're looking at putting in place some additional deprecation flags to make the downstream consumers aware that this is going to change in the future, but we also need to make sure to give them enough time to switch over. Things shouldn't have changed that much. I mean, the libraries all still have the same name. Yes, the build directory you build in may be different, and it does depend on how you actually build it, because there's nothing to stop you using a Maison build folder called x86-64 native Linux GCC if you wanted.
I think
somebody else, I see Luca's waving frantically there. Maybe he's got a response to this, if we can get him a mic. Okay, so there you go. Canonical are doing it and it works.
Okay. So one other, I guess you were looking for feedback.
Yep.
So I want some configurability, but most of my configurability is around debug, right? So I want to be able to turn off AVX or SSE, right? Because I want to see the performance in, straight non-vectored mode versus, different forms of vector mode. And I mean, I'd be willing to say if there was just some debug option, right, that I could say, okay, this isn't going to really, happen, but I want to be able to turn these things off in a pull mode driver. Those are the kinds of things that I want to do and that are missing from Maison, right? Because I have to go
but that's assuming that needs to go into Maison. So my response to that is if you want to test out the different receive paths or transmit paths or debug paths, that should be a runtime option rather than a build time one. So that we're always building all the paths of the code, because what will happen is if we have a debug option in the build that turns on this code path rather than that code path, whatever the default is, people will compile before they submit their patches, and they won't compile the other one, and things will break. So I'd much rather see for something like that, especially talking about turning on and off vector, that I think should be a runtime option rather than a build time option. And that's a general trend that we on the technical board want to see in DPDK, is any options that can be made runtime should be made runtime and not put into the build system, because it means those options can't be packaged. Just talk to Luke about Devon packaging, or the guys from Red Hat about for their packaging, how much trouble how much they dislike these build time options for things like that, because they just can't package both options.
So for 1911, you're marking it deprecated, meaning you're marking make deprecated. So that means that Maison is fully production quality and preferred over make.
Yes.
So you will reach that maturity level at 1911 with Maison.
I believe so, yes. but that if there are gaps that are causing problems, we can reevaluate that decision. I have no problem with pushing it out in an additional release if it is seriously deficient.
Okay, so regarding, in principle, I don't mind compiling in all the libraries, including the ones we don't use, if they don't impact startup time significantly, and if they don't impact memory consumption significantly. And of course, drivers should be separate, so we can add or remove drivers. I agree with you on that.
So you'd like the configurability to turn off building some of the drivers. You're presumably for your product, then you're building your own copy of DPDK. You're not using a prepackaged one.
Yes. So I'm libraries. If there are some libraries I'm not using, I would prefer not to have them. But I don't mind having them if they don't impact memory or startup time.
So ideally, if your library, the linker shouldn't even link them into your application if you're not using them.
Yes.
Right.
Just a comment on how as it is. In Debian and Ubuntu, we've been shipping DPDK built with Meson since 1811. We haven't seen any problems with that. So, from my point of view, it is.
That's you don't have the option to disable libraries you don't use.
No.
No, but we need that. We might need that.
Instead of having 40 libraries generated by build system, can we just generate one single SO, which is called dpdk.so? It makes easier the configuration problem. It makes easier to ABI versioning because there will be a single ABI, and also it may help packaging guys perhaps that there will be only one library. With the conditions Morten mentioned, they are not consuming more memory or adding to initialization time.
Interesting proposal. I don't think it's for me to answer.
Yeah, why not?
Anybody? I mean, I wouldn't have a problem with that, but see what others think.
Yeah, just a question. So, like, in terms of test PMD, I suppose I'm wondering, is it time to split DPDK into like a core set of libraries and an extras? Because if you look at test PMD and it uses things like latency stats and BPF, and you know what I'd say is kind of non-core libraries. I wonder, is it a time to think about core libraries and say, you know, that everyone will use, and then have a kind of an extras?
Potentially. It has been discussed before. The discussion never really went anywhere. These would be good topics actually for a discussion panel at some point. I don't have a good answer to that. It's perhaps something that needs to be discussed on the mailing list. I suspect the issue will be, you know, your definition of what is a core library. There, you know, maybe some debates about that could get interesting.
Yeah. Well, again, Stephen did some presentation where he looked at a lot of like which libraries were used. I think that's probably a good indication. Yep,
it is, and maybe I could see the case too that we may want to take a close look at the number of libraries we have and see, you know, down the road, do we want to maybe remove one or two if nobody's really using them? It's another option, but splitting to core and extras, yep, could be a potential too. Would you see just one extras package or a set of extras packages? That's then the next question.
Keep it simple for the start, but yeah, because I think test PMD is very widely used. Yeah. And that's the one that has a lot of dependencies. I think that might be the most troubling, like in terms of, you know, having to ship a latency stats or a BPF with it.
Okay. I'm well over time, I think, at this stage. For a last word.
I mentioned this in tech board as well, but does it make sense to have a wrapper, very simple make file to keep compatibility with the old commands so that people's build systems can work? Like make config can be a wrapper to Meson configuration. So does it have a value? Just a comment.
We can do it. Does it have value?
One of the things to consider when switching to Meson is that the development model changes a little. So you no longer have the SDK model, you have the PKG config stuff. So there might be some value in keeping some backward compatibility command, but you still need to change your model when we switch.
I think I better leave it there, but I'm happy enough to discuss this more with people at the breaks and at lunch and so on. So thank you.
So the next talk will be by